11th graders. This is Mr. Klinkerman. This is your first flipped classroom lesson. I'm pretty excited about the whole concept of a flipped classroom. The idea, I've explained it before, but I'll explain it again right now, is that I'm going to start teaching you through little videos such as the one that you're about to see right here, which will in turn allow you to do your practice, what formerly was homework, within class in an environment where you're going to be able to get supervised help. When Mr. Pollock and I are both in the classroom, that means that you've got two experts working with you anytime you're doing your practice problems, which increases your chance of practicing correctly, which in turn increases your chances of doing well in quizzes and tests. That's the theory. Let's put it into practice. One of the things I want you to think about whenever you're watching one of my videos is that this is your lesson and that you ought to be taking notes. There will be times where I'll tell you to pause a video and work examples for yourself. You ought to do that, give a good faith effort, and then see me whenever I show you how to do those examples. But make sure you're writing down main concepts, copying down examples. That way you have a reference when you're not watching the video as well. One of the things I'll do every time I make a video is I'm going to write down the learning goals for the section that we're in. And often, as is the case here, I'm going to break those learning goals down into a couple of different videos. Now truly this is out of the order that the textbook does it, but I like this order a little bit better. What we're learning in section 1.5 is about what are called inverse functions. We talked about those briefly in class the other day. And where we're going to begin with inverse functions is by learning to find the inverse of a function algebraically. And then we're also going to determine whether its inverse is also a function, which turns out to be a fairly simple thing to do. Then, in a separate video, we're going to concentrate on learning goal number 2, which intends for you to learn the graphical relationship between a function and its inverse, and to apply what's called the horizontal line test to determine whether a function has an inverse that is also a function. Let's get on with goal number 1, which again is trying to find the inverse of a function algebraically. Before we can answer the question how you find an inverse algebraically though, you need to know what an inverse is, and so we're going to answer that question, what is an inverse? Alright. You know that we have studied relations and functions in this section, and what we're going to do is we're going to suppose that we have a function that maps a value A to a value B. Well, the idea of an inverse is that it simply undoes what a function does to a number. So where this function f is mapping the value A to B, what the inverse of that function will do is it will map B back to A. For example then, if function f took the number 10 and mapped it to 25, then the inverse of the function will take 25 and map it back to 10. Alright, if f of 10 equals 25, then f inverse of 25 is equal to 10. Now I want to make sure I make a note about the notation you use whenever you're referring to an inverse, because what it looks like is f to the negative first power, but that's not really an exponent right there. Anytime you see the name of a function followed by that negative one that looks like an exponent, the way you read that is f inverse or the inverse of function f. Now the notation is related to exponents. You might remember that if I have 3 to the negative first power, for instance, that's equal to 1/3, and 1/3 is what's called the multiplicative inverse of 3. But I don't want you to think of that as an exponent at all. That just means the inverse of a function, and it's just some notation that you got to learn and get used to. Okay, well, let's move on a little bit then. And what I'd like to do is show you some examples of some functions and the inverses of those functions. And it turns out that some very simple functions, you can find their inverses through reasoning. Now I want you to look at this function y equals 2x minus 5. And I want you to think about what that function does to its input value. What that function does is first it doubles the input value and then it subtracts 5 from the result. Now this is kind of like a socks and shoes principle. Whenever you put your socks and shoes on in the morning, you put your socks on first and then you put your shoes on. But when you're trying to undo that, you have to do the opposite thing in the opposite order. Instead of putting on your socks and then putting on your shoes, you take off your shoes and then you take off your socks. Here's what I mean mathematically. This function doubles the input value and then subtracts 5 from it. So the inverse of that function would first add 5 to its input value and then divide by 2. Another example. Here's a function that first adds 3 to its input value and then it takes the square root of the result. Well, the inverse of that would instead square an input value and then subtract 3 from the result. Opposite operations in the opposite order. All right, and then finally, if you have a function where you subtract 4 from the input value first and then you cube the result, the inverse will take the cube root of the inverse value and then add 4 to it. Hopefully that makes sense, but I'm going to give you an actual method to find the value of an inverse rather than just having to use logic the way that I did. Let's talk about what that method is going to be. I want to show you an example of a function here that maps some numbers to some other certain other values. We're going to say that there's a function f that maps -3 to 8, 5 to 24, and 9 to 80. All right, so for instance, then that means f of -3 is equal to 8. That's what I'm trying to get across to you. Well, the inverse of that function ought to make it such that the inverse of f, or the inverse function f of 8 would get you back to -3, right? Look at this. Here's an example of the inverse function, where 8 gets mapped back to -3, 24 gets mapped back to 5, and 80 gets mapped to 9. Here's what we've done. There's 2 ways of explaining it. Whenever you try to make the inverse of a function from the function itself, one thing you can do is you can say that you switch the domain and the range of the function with one another. All right? So the domain here of the inverse was the range of the function, and the range of the inverse was the domain of the function. Another way of looking at that is that you just take the x values and the y values from the function and you switch them. All right? What used to be the x values for the function have become the y values for the inverse, and what were the y values for the function have become the x values for the inverse. In other words, if you want to find the inverse of a function, really all you have to do is switch the x and y values with one another. Now, you don't always have a list of all the x and y values that are part of a relation or function. Most of the time, in fact, when you're dealing with inverses, what's going to happen is that you're going to be given the equation that relates the x and y values in a function. And that's the case here. And I want to show you then how you're going to go about finding the inverse of a function when you're given that function in equation form. And this basic process works just the way I described in the previous slide. What we're going to do is we're going to switch x and y to begin. Now, one minor detail. This function is written using function notation, where we wrote f of x equals 2/3 x minus 5. But of course, that's equivalent to writing y equals 2/3 x minus 5. And it's going to be easier to switch x and y if you actually have the letter y there instead of f of x. Now what we're going to do to find the inverse, which I'll just label as f inverse, I'm going to put a colon here, is we're simply going to make that x equals 2/3 y minus 5. Alright, now this is the inverse of function f. However, it's not how we're going to leave the answer. Because what we'd like to do is we'd like to set up the inverse so that you input x values and get y values. And right now we've got it set up so that you would input a y value and get an x value. Hopefully that makes a little bit of sense. And so after you have switched the x and y values, the second thing that you do in order to find the inverse of a function in equation form is you then solve for y. Now to solve this equation for y, you're simply going to show off your algebra prowess. To get y by itself here, we're going to start by adding 5 to both sides. So that'll give us x plus 5 is equal to 2/3 y. And then to get rid of the fractional coefficient that's joined to the y, we're going to multiply both sides by the reciprocal of that coefficient, which is 3/2. So we'll get 3/2 times x plus 5 is equal to y. The final piece of this is that I would like you to write the function's inverse in function notation. But instead of writing f of x as you usually would, you'll just write f inverse of x equals, and then you'll put the equation 3/2 times the sum of x and 5. So to summarize there, to find the inverse of a function, you switch the x and y values, and then you solve the equation for y. Let's do another example. And in fact, this is one of those times where I would like you to pause the video, and I would like you to go ahead and find that inverse on your own, and then hit play again and watch me work it out to check your answer. And there will be one little trick at the end of this one, and you'll understand it completely whenever we get there. Go ahead and pause the video, find the inverse of f of x equals 4x squared minus 9. Alright, I'd like you to check your work with mine. You can see how I began by rewriting the function from function notation into y equals form. And then we switched the x and the y, so there's x and there's the y now. And I solved the equation for y, which required me to add 9 to both sides, then divide both sides by 4, and then take the square root. And I'm pretty happy if you got it right there. However, remember that whenever you have a variable squared and you're trying to solve for that variable, something as simple as x squared equals 16, that you have to take the positive and negative square root in order to find out all the values of x that would make that equation true. Both 4 squared and negative 4 squared, or 16, had to get both those results. And that is the same thing that is happening here. We had y squared, and so whenever we solve, we can't just say it's the square root of x plus 9 over 4. We have to say it's plus or minus the square root of x plus 9 over 4. Alright, and then in function notation, what that means is that f inverse of x is equal to plus or minus the square root of x plus 9 over 4. Now, one last thing I want to talk about with this. I want to talk about, is this inverse a function? The original equation was a function, but is the inverse a function? And the answer to that is no, and I need to illustrate that. Now you can do the math on your own here in a moment, but let me just give an example. Let's suppose that I wanted to find out what f inverse of, let's say, 16 is. Now, f inverse of 16 would end up giving you plus or minus the square root of 25 over 4, which gives you plus or minus 5/2. Now, I'm going to erase all this drawing stuff and summarize what I'm trying to tell you here. That means that with this f inverse, that if I have 16 for my input, I could get either positive 5/2 or I could get negative 5/2 for my output. And since I have a single input with more than one output, f inverse is not a function. So there will be times where you find the inverse of a function, but the inverse itself is not a function. Got one more example that I want you to try, and then you'll be done with the notes. Nothing fancy about this one. Just go ahead and pause the video, try to find the inverse, and then check your work at the end. Well, there you go. There's all the work. You see that the inverse ends up being f inverse of x equals x cubed minus 1 over 6. I promise that that is a function. No matter what value you input for x, you're going to get only one output value for y. So you don't have to worry about whether this is a function or not. It is. Great job working with me on finding inverses of functions. The next video that you watch is going to show you how to use the graph of a function to determine if its inverse is going to be a function. And we'll just generally examine the relationship between the graph of a relation and its inverse. I'll see you then. Later.